Let's hope the coffee machine is working, and let's get started. So in this talk, I'm going to talk about how to build KiCad plugins. And this is the outline. So it's let's talk about the scripting interface and about this console, about the structure of a KiCad action plugin. Let's build one, and then talk about how to get it into the plugin and content manager so we can publish it for others to use. So my stated goal of this talk is you should know exactly where to start when you want to write your own plugin afterwards, and you should be able to publish it. So to begin with, I have like 2 or 3 questions. Who of you already uses plugins in KiCad? Okay, so for the online audience, it's almost everyone in a room of about 100 people or so, probably more. Next question, who already wrote a KiCad plugin? That's about maybe 10 people or so 10%, that's great, that's perfect. It also says join the friendly development team. So another question is, who of you considers yourself a KiCad developer? That's about 5 people. And now Lucas, who of you considers yourself a KiCad user? Okay, that's pretty much everyone. Okay, so about me, I'm a KiCad user myself. I'm a computer engineer by education, but nowadays usually I write memory-safe firmware in Rust. But hardware is hard, and it often doesn't work. So I like to design it myself to make sure it works, or to make sure it doesn't work. It depends. I've been using KiCad since the 4.0 release, so it's almost 9 years ago now. Time flies. And when I need to automate repetitive things, I tend to write a plugin. So why write plugins? Open source is awesome because you can improve it. I really think this is one of the greatest selling points of KiCad over like Altium or whatever other people use. So if you need something, you could build it yourself. Sometimes you can't bring your changes upstream because your needed feature is quite specialized, or because you can't maintain the needed code quality. I mean, it's a real thing. Like, you're not shipping the code, you're shipping the product you built with KiCad. So you might not be a software developer. Your code is quite hacky. Of course, you could run your own fork, but that also requires effort. And then you could just put that effort into bringing your changes upstream. So plugins are much less invasive. You don't need to dive into the inner workings of KiCad as much, and you can still contribute them with the plugin and content manager if desired. So if you can answer one of these questions with yes, then you should consider writing a plugin. So you find yourself repeating the same task frequently, needing functionality that KiCad doesn't provide out of the box. You want to integrate it with other tools in your workflow. Maybe like even use some external databases or something like this. And then a plugin is a great way because you can have it just locally. It would be no use for other people. You may have domain-specific requirements, or you might want to streamline productivity in your workflow. Okay, so let's look at the foundations of this scripting interface. So right now there's a Python-based scripting interface. It's Python 3 only. Python 2 has been deprecated for a few years. It's a simplified wrapper and interface generator. So it's called Swig, and it generates Python bindings out of the underlying code. So it's no true API, but instead it's like a raw binding layer over KiCad. And this also means it's unstable and changes between KiCad major versions, but I found it to not change really much. So because KiCad itself is quite stable. There's an inter-process communication API planned for the future. And the future right now, I think, is 9.0. And it uses protocol buffer-defined messages, and it's passed with NNG. I think it's nano message NG next generation over Unix sockets. So there's more info under the link. And this Python-based scripting interface right now is only available for PCB-New and the Footprint Wizard. So it's not available yet for EE schema. So what can we do with this? We can interact with the core functionality, that is with the PCB data and footprints, and we can then modify the board layout, add components, whatever. And we can also add our custom dialog to the plugin. But it can also be used standalone, so you don't need to have a running instance of the PCB editor, which means you can just edit like files, have like a, I don't know, action script, or in your continuous integration that adds whatever to your board. So usually the board is loaded with like pcbnew.getBoard, so you say import pcbnew, and then you have like these functions like get footprints, get drawings, get tracks, and then you can call them and get their objects, and yeah, or create new ones and add them to the board. So if there's no running instance of pcbnew, you can load the file name like this, and you can also save the board again. And when you find yourself developing it, you might want to check the doxygen documentation, which is auto-generated from the Python bindings, and it's, yeah, like normally useful like such a documentation already is. So then you might want to start experimenting with it, and the best way to do that is a scripting console. So you can just go to Tools and open the scripting console and the PCBnew, and it looks like this. And then you can just tinker around. The important thing is the API is not automatically loaded, so you need to say import pcbnew, and then you can say pcbnew.getBoard, and then you can do whatever you want to do. So if you like found some use case that you want to do, and now you want to write a plugin, you need to put it into a kind of structure and order. So the first thing is it needs to be in the plugin search path, which is any of these locations, but it's really the easiest is just to open the plugin and content manager and then say open package directory, maybe. Or if you go into pcbnew and then you say tools, plugins, you can also open the folder, but I'm not sure if they're the same, but either both of them open one of those folders. And then the folder structure is like this. Inside the plugin folder, you can have, if you're having a basic plugin, you just need a Python file, a single Python file. You can have an icon for it if you want to include it in the toolbar. And more complex plugins, you maybe have several Python files for like your user interface, maybe some classes. Then you should put them into a separate folder, and there should be an init.py inside. Yeah. And if you look inside your plugin folder and you have installed plugins via the plugin package and content manager, then you will see they are named in this reverse DNS format from the metadata file, but we'll see that later on. So just in case you're wondering what you're finding there, this is the installed plugins are residing in the same location. Okay, so let's take a look at a simple plugin. This is the basic structure. This is the most simple bootstrapping you need to do. So you create a new class, and it's based on a PCBnew action plugin. And you need a name, category, and description. You also have some other files, some other parameters, not files, that are optional, like if it should be displayed in the toolbar or not, although the user can override this with the KiCad setting. And then you say in the run function, which is executed when you actually press on it, you load the board, and then you can do whatever you want to do. And then you need to register it. If you have a multi-file plugin, you put the register in the init.py, and then you have like action.py file where you put in the actual Python logic. So then, let's look at a somewhat useful example. You could do this. Like this hides all reference designators. It's apparently so useful that there's 2 plugins that do this in the plugin and content manager, and I wrote only one of them, so I don't know who wrote the second one. But let's have a look at a more practical example. Let's have some spiraling thoughts. Some people build amazing things with PCBs, and I don't know, maybe you've seen these PCB motors. Those are from Carl Bugea, I think, on YouTube. So, this seems annoying. We want to automate it. Okay, let's write a plugin that draws spiral traces on a PCB. We want to have a dialog where the user can define parameters, like the radius, number of windings, the width of the traces. And give a position so that it can be positioned on the board. And of course, we want to specify whether it's clockwise or counterclockwise. Yeah, so we see user interface creation, we see how to manipulate the PCB, and some calculations. So the first thing we do is we import PCB new. We also import WX for the dialog interface. And yeah, this is like before. But then we create our dialog. So we have another class, spiral dialog, which is called wx.dialog. And yeah, then we have this. We can specify the window size, and we can add some labels and some text control. So yeah, now we have a text box, and to the left of it, there's labels that says outer radius. And then we do the same with everything else that we need, like the inner radius and the trace width and so on. And in the end, we just add an OK button and a cancel button. So they are defined in the bottom, and then they're added like this. So then we want to handle the user input. So we write our function like so. And we see how it's used in the run function in the next step. And then we just call the getValue function on all of our fields. For the direction choice, we have a drop-down, and we have a string selection. We have like clockwise and counterclockwise. And if one of them is not valid numeric, then we'll get an value error, and we say to the user that they should enter valid numeric values. Okay, so there's our run function, and then we say like values is dialog.getValues, and then yeah, we assign them to like variables again, so we can use it. And then one interesting thing that we see right now here is I create a vector 2i for the x and y coordinates, where we want to start with our spiral. And you see this times 1 million. This is because KiCad uses like nanometer internally. But there's also a vector 2i underscore millimeter function if you want to use that one. Exactly. So then let's take a look at the business logic. Basically, we do like the calculations of our radius, of how it increases. And then there are multiple ways to go about this. But my idea was to just use arcs that increase in size, so half arcs, because it will approximate a spiral good enough, and it doesn't require so much compute because you have really few objects. Yeah, and then we create an array for the drawn arcs, because in the end we want to select them all if the user wants to move them immediately. So then for each winding, we create this arc, and we have a start point, midpoint, and end point. So it's an arc defined by 3 points. And yeah, we add it to the PCB, and then we need to do it for the, then we have the like lower half of the spiral. We need to do it for the upper half as well. Yeah, so it's basically the same, but offset by 0.5 there. So I will show you the results of this afterwards. So now we want to share it, to upload it to the plugin and content manager. So how do we do this? The workflow is really nicely documented under devdocs.kicad.org/n/addons. And basically what you need to do is you have to have a repository, and inside of it you have a plugins folder and resources and metadata.json. And inside this metadata.json, you put in like some details about the plugins which are needed so you can contribute it. And of course, you should add an icon. And for icons, icons for the plugin and content manager should be 64 by 64 pixels, and toolbar icons. So these should be in the resources folder, and then you can have an icon that's 24 by 24 pixels. That's for the toolbar, and that should be inside the plugins folder. Then let's take a look at this metadata.json. So this is an example. So you have like a short description and a full description. Then you have this identifier, which is like which should represent the reverse DNS of your repository, wherever it lies. So if you have it on github.com/KiCad user/KiCad beautiful theme, it should look like this. Yeah, then you can say what type of it is, if it's like a color theme or an action plugin. Put in your name and contact, and you also need to put in like a repository or homepage, like in here. And then down there you have this versions struct, and there you need to put in a SHA-256 of your zip in the end, and what's the download size and what's the size after it's extracted. So these download underscore things should not be in your repository. In the end, they should just be contributed to the KiCad add-on repository. But it's explained in detail in the add-ons guide. I found it's a bit finicky getting this to work because like you need to make some changes and you forget to update the SHA hash and so on, like it's always with these things, so it's best to automate it. And yeah, KiCad developers are awesome, so they added a few helper scripts to help you with this process in the add-on repo. And some people also have created like a GitHub action that does this automatically. But yeah, you know, KiCad is hosted on GitLab, so you need to create an authorization token for your GitLab account and then give it the correct access rights. And then you need to have a fork, and then it pushes it automatically onto your fork. So yeah, you might want to do this or not want to do this, but yeah, it can be helpful. So then after you build it, of course, before you add it, you test it thoroughly. Like you use a built-in Python console for quick tests, and then you create like a test PCB file and handle all your edge and corner cases there. And then you install older KiCad versions if you want to ensure compatibility. Yeah, so just to summarize it, if you want to submit it, you can create your own action plugin. You should follow the PEP 8 Python style guide, then structure it correctly, like in the folder hierarchy, include this metadata.json file, then package it into a zip archive, then create the SHA hash, add this, and then you host it on a publicly accessible URL, like most people do GitHub release pages and have the zip file there, and then you take that link and add it into the metadata.json, and then you open a pull request in the add-ons repository. And then afterwards, of course, you maintain your package. So you have your source code somewhere where issues can be reported and tracked, like GitHub or GitLab. You should be reachable and respond to bug reports within 90 days and update it. Otherwise, the plugin will get marked as abandoned. Okay, so how to work around some of the limitations. This is software, and as always in software, some things that might seem simple are actually hard, and vice versa. So one example is this wire stitching generator. You might think, well, just add some wires. But if you if you think about it, what do I need to check when I want to place a wire? Like, there should be a ground plane. No, there should be two ground planes because you want to connect them. Then you want to check that the position where you want to place your wire is not occupied, but then your wire has a diameter. So you need to check a radius around that position, and this should be free. So yeah, just try things out very early to see if it's actually as simple as you think, or other way around. If you think it's really hard, try it out. It might be much simpler. Then there's this missing eSchema scripting interface. And eSchema doesn't have a scripting interface yet. I don't know if it will ever see those Python bindings. No, it won't. Okay, that's great. So that makes no sense. But just, yeah, it was planned for KiCad 6.0. Also for KiCad 7 and 8. So now it will be added with the KiCad 9.0, the NICE API. But let's show some love to the KiCad developers. This is what the burndown chart for KiCad 9.0 looked as of yesterday. So it's really easy to open an issue or to add something to the wish list, and it's hard to implement things. So if you like KiCad and you know how to write code, like especially C++ code, then yeah, let's see if you can tackle some of the issues and help get those features into 9.0. But people worked around it, so if you can't wait until March, KiCad schematic files are plain text files, so you can modify them, and people wrote like a parser that allows you to parse it and then save it. Yeah, one of those files is called KiCad Skip, and there's the guy that wrote it also had like a blog post where they made an LED array and automated this. Yeah, so let's sum it up. KiCad plugins are great, and they have like a lot of potential for customization and automation. They allow you to tailor KiCad to your needs. It also helps you to like dive into KiCad's internals if you want to like do some work on upstream KiCad later on. And yeah, the community benefits from shared innovations, so build something and then share it. Start small. It's always easier to build on top of something than to do it perfectly right the first time. Experiment early on, so you can find what works and what doesn't. And don't be discouraged by initial complexity. Like if you're into it, it doesn't seem that complex anymore. So you can ask the KiCad community. It's really great. So next steps for you, some homework. Identify a repetitive task in your workflow to automate, and then spend 10 hours automating this task that you spend 10 minutes a month. Yeah, explore existing plugins for inspiration. Some of those are quite large, so they're really a good overview of the feature set of the API. Start with the scripting console to experiment. Yeah, then of course consider contributing your plugin to the repository, and stay tuned for the upcoming developments, especially if like you don't like Python, because the next version is protocol buffers based. You should be able to just get those struct in whatever programming language you use if you want to get it in, and then you can write your KiCad plugins in Rust or whatever you're into. So yeah, it's a journey. Start small and grow your skills. Your contributions can improve it, and remember, the best plugin is the one that solves your problem, so don't try to do it all, and the power is in your hands. So I've added some resources for further learning. I also have a QR code to the slides later on, so you can download them, then you have all of this. And before I show you this and go to the questions, I'll just want to show the Spiral plugin real quick. Let's say mirror. Okay, so I have this KiCad project which is aptly titled Untitled. And then we can check out this plugin that we wrote earlier. So let's say we want to have 10 millimeters outer radius, I don't know, maybe 1 millimeter inner radius, 10 windings, 0.2 is a reasonable trade width for whatever we're doing, and place it at 100, 100. And let's say clockwise is all right. Yeah, and then this is what we built earlier. So yeah, it's pretty simple, but I wouldn't know how I would do this otherwise. So I certainly wouldn't start doing it manually. I'm too lazy for that. All right, so let's get back to the I mean, if I remembered the page number, I could have typed it in, but of course I didn't. Yeah, questions. I'll leave this one up, so if you want to ask the slides.
Thanks for a great presentation. I think the plugin is a very good part of KiCad. In an earlier version, I don't know if it was 6 or 7, I tried to do a plugin, and I was a bit frustrated about the API didn't seem up to date at that point. And when I inquired about it, it was like, well, we're going to change the whole plugin system, maybe the Python interface, so we don't want to update the API. And I felt it was kind of like a chicken and an egg situation where, there's always going to be changes. So if you don't want to change or update the API, and do you know if that situation has become better? And also, I have 2 questions. When there's an update of KiCad, does that, make the plugins unusable, or do we have to wait for a plugin to be modified to accommodate the changes in the versions?
Yeah, okay, perfect. Thank you for your question. So regarding question number 2, it sometimes breaks, because it's generated directly, those Python bindings. For example, between KiCad 7 and 8, no, 6 and 7, I'm not sure. There was a get modules functions, and afterwards there was a get footprints functions, and this gave you the footprints, and before it, footprints were like a module, so that changed. And then you build some if else, if this function is available or not. Concerning the Python bindings being out of date with the KiCad underlying, I've not experienced that. Maybe for nightly, but it can't happen because it's auto-generated. But for the nightly versions, it might break, of course, but then it will get fixed after a few days. So that's what you're there for if you're using nightly. Yeah, but also the new IPC API is like a proper API. It's stable, so everything will get much better in March.
Okay, I have one more comment, just a comment. We had this contribution day half a year ago, KiCad, Learn to Code or what it was. I would really appreciate like a plugin day or something like that. Just what I would like to see. Thanks.
I'm sure somebody will talk once the new IPC. Yeah. I can kind of somewhat answer that. I think once the version 9 is released in beginning of next year, the IPC, somebody will do a talk on creating IPC plugins. I'm almost sure of that. Right now there's Python and Rust bindings. I suspect the other bindings will be forthcoming.
So come to KiCon US in May.
Hi, thanks for your talk. I was wondering if there's some sort of cookbook for simple tasks, basically showing you how to interact. For example, iterate over all parts and change some property or whatever. Because I was looking at some existing plugin and it did quite a lot, and that actually made it hard to understand what is going on.
Yeah, so in those resources, there's like this sort of plugin primer that was written for 5.1, so it's not so up to date, but it's like a quite good overview. And then those other, like the Python bindings overview and the reference manuals, they are like a very basic starting point, so they don't have those cookbook styles. But it's quite some effort to maintain something like this, so I really see how useful it would be, but documentation is always a great thing to contribute because you don't need to know how to code, so it's quite low barrier. So once the IPC plugin is out there, I think that's a great idea, and I'll take a look at it.
Looking at the dev docs right now, it says don't use the Python bindings, it's going to be deprecated. Do you know to what extent those are going to, the new Python binding on top of the new API will be more or less the same as the old ones, or are they just going to change entirely?
So there will be a deprecation notice for the old one once it's out, and then it will be removed 1 year afterwards. So like everybody needs to update their plugins, and it's a fundamentally different approach. So I don't think I can't see how there would be compatibility, but I also think it's not a good idea to have that kind of backwards compatibility, because this will make things so much better. It's okay to have some effort required, and I think most plugins are very actively maintained, and people will switch it over quite quickly.
Okay, thank you so much.